Today I am going to discuss about basic concepts related with climatology, and in this session I will be discussing about atmosphere, its composition and its structure. See, first of all, what do you mean by atmosphere? Atmosphere means the thick gaseous envelope surrounding the earth. Okay, and this gaseous envelope, it is attached to the earth's surface due to the gravity. So due to the earth's gravitational force, atmosphere is there. Otherwise the planet earth won't be having atmosphere. The next thing, 99% of mass is within the height of 32 kilometer. See, UPSC, you can expect these kind of statement related questions. Okay, majority of the mass of the atmosphere is limited to or within 32 kilometers. Now another thing regarding the atmosphere is it acts as a greenhouse by trapping the heat. Now see, if it were not for the greenhouse property of the atmosphere, life wouldn't have survived here in earth. Okay, so through the greenhouse effect, the atmosphere traps the heat so that the life can survive here. Fine. And next we look at the origin of the atmosphere. See, there are three major processes or phases through which the atmosphere has evolved. One, the loss of the primordial atmosphere. Primordial means the atmosphere which we had at the initial stage. See, the present atmosphere, its composition and its structure, everything is different from the primordial atmosphere. So the primordial atmosphere, it was taken away due to the solar wind. See, solar wind means the highly charged particles and everything coming from the sun. Okay, so the first stage in the evolution is this primordial atmosphere was taken away due to the solar wind. So if they ask is solar wind having any influence on evolution of the atmosphere? Yes, right? So next is degassing. So this term, it means ejecting gases. So when earth began to cool down, what happened is that the gases, especially the water vapor and the carbon dioxide from the interior of the earth, they began to eject towards the atmosphere. And now the present composition of the atmosphere, it is mainly due to this degassing. So again, remember this term. The next is photosynthesis. See, the importance of photosynthesis is creating free oxygen molecules. So the three things which has influenced the evolution of atmosphere is one, the loss of primordial atmosphere, then second, degassing, then third, photosynthesis. Okay, now let's see about the composition of the atmosphere. Regarding composition of the atmosphere, atmosphere is made up of mainly three things: gases, water vapor and the particulate matter. Okay, first let's look at gases. See, these are the percentage of the gases or percentage by volume. You should remember the percentage or the average values of nitrogen, oxygen and carbon dioxide. Okay, now in the case of nitrogen, see, nitrogen not necessarily always take part in chemical reaction with other elements. So generally they are inert, but they are not entirely inert gas, rather they don't take part in much of the chemical reaction. Okay, now regarding the carbon dioxide, the carbon dioxide, it is constantly in news, right? You might be knowing it is constantly in news, and it is because it is having greenhouse effect and resulting in global warming and in turn resulting in climate change, right? So what causes the property of this greenhouse effect? Because the insolation or the radiation coming from the sun, which is called as insolation, it is short wavelength radiation. The carbon dioxide is transparent to short wavelength radiation, and the radiation which is given off by the earth, okay, it is called as terrestrial radiation, and it is long wave radiation or infrared radiations. So the incoming solar radiations, they are short wavelength, and the terrestrial radiation which is going back from the earth, it is a long wave radiation or infrared, and carbon dioxide is transparent to the short wavelength radiation and opaque to the long wave radiation, so that the heat will be trapped inside. Fine. Now next, let's look at the water vapor. See, one thing regarding water vapor, see, first of all, its state. The state of the water vapor is gas, but even then it is not included in the previous list, right? It's because the percentage of the water vapor, it's variable, it's not constant in anywhere of the world. The water vapor, it is distributed likewise, if we go from the equator towards the polar regions, see, in the equator more insulation will be there and will be more evaporation will be there, so that the water vapor percentage will be more in the equator. and when we go towards polar regions, it will decrease, right? Now consider if we are going from oceans or from coastal areas towards the interior of the continents. Okay, in that case also the percentage of the water vapor will decrease. Now the density of the water vapor comparing to the air or the air particles, it's higher, so that the general tendency of the water vapor will be to get segregated under the bottom layers. Okay, so with altitude the percentage of the water vapor will decrease. So the majority of the water vapor will be seen in the troposphere or in the bottom layer of the atmosphere. Okay, so water vapor is a variable gas. Then second, it can absorb both insolation and terrestrial radiation. So in the case of carbon dioxide, it absorbs only the terrestrial radiation, right? It is transparent to insolation. But in the case of water vapor, it can absorb insolation as well as like terrestrial radiation. See, if you have noticed this, like say after shower, like if you again enter the bathroom, like it will be more hot there, right? It's because the water vapor will be retaining the heat which is taken off from our body. Okay, so should remember that the water vapor can absorb both of the radiations. And next is latent heat. See, latent heat means the energy given off during change of state. It simply means when water is changing to water vapor, we will have to provide certain energy, right? Now if the water vapor is changing back to water, that energy will be released. Okay, so this amount of absorbed energy or released energy, we call it as latent heat. Now why it is important? Because like for certain weather events, like consider tropical cyclone. See, tropical cyclones don't form over the continents, right? Whenever they make landfall, they will negate. It's because like they need the presence of atmospheric moisture, and the presence of atmospheric moisture means when it is condensing, the heat will be released, and this heat is necessary for tropical cyclones. Likewise, say consider thunderstorms. It is also like the latent heat which is given off by the water vapor is again necessary for the formation of thunderstorms. So in the perspective of climatology, the water vapor distribution affects the climatic type of a region. Okay, so these are the important things regarding water vapor. One, it is variable gas, then it can absorb both insolation as well as terrestrial radiation, and third one, the latent heat which is affecting the climate as well as like certain weather event. And next, let's look at particulate matter. See, particulate matter means anything which is suspended in the atmosphere. See, mostly like we will be hearing this term in the context of air pollution, especially in the case of Delhi, and it will be mentioning as like PM 2.5 or PM 10. So this numerical value represents the size of these particles which is suspended in the atmosphere. So the importance of PM particle is that they act as hygroscopic nuclei. See, hygroscopic means water seeking. See, suppose if you have noticed, like during the early morning period, like we will be having fog formations, right? And why the fog formations, and will it be there in the higher atmosphere? No, we will be seeing it in the bottom layers, right? Now why the fog formation is there? Because at night time, the water vapor as well as the dust particles will get segregated in the bottom layer, and the dust particles or the PM particles, they will provide a surface for water vapor to condense, resulting in fog formations. So the property of PM particle is that they are water seeking. Next, it scatters incoming solar radiation. See, if you notice, like during daytime, the sky will be in blue color, and during night time, the sky will be having orangish and reddish color, right? And this is due to the scattering property of PM particles. When the PM particles, they are very fine in nature, and when their size is very fine, the scattering will result in blue color. And if the particle size is higher, the scattering will result in reddish and orangish color or hue. Okay. So next, let's discuss about the structure of the atmosphere. The prime thing you should remember about the structure of the atmosphere, it's layered in nature, or it's stratified. Okay, and atmosphere, it is having both homogeneous as well as heterogeneous nature. Homogeneous means same property, heterogeneous means different property, right? So homogeneous in this context means like the chemical composition will be same, same everywhere. And in the case of heterogeneous means the chemical composition will be different. So we are having three homogeneous layers. One troposphere, then second stratosphere, then third mesosphere. See, these three layers, they can be called as thermal layers or homogeneous layers. And the other layers like ionosphere or exosphere are generally called as thermosphere. They are heterogeneous layers. They won't be having like same chemical composition everywhere. And regarding the density of the atmosphere, see, the density of the atmosphere will be higher in the bottom layers. Okay, so the denser the material or denser the gases, it will get segregated in the bottom layer of the atmosphere. You must have noticed helium balloons, right? The helium balloons, if you release them, they will go to the upper atmosphere, right? Because the helium is generally lighter when compared with the other gases. So they will go to the upper atmosphere. Likewise, as the height increases, the density of the atmosphere, it will decrease. Now another thing regarding the structure is, like if you notice this figure, now as in the y axis we are given altitude. So as the height increases, the temperature will decrease in the troposphere. Okay, and in the case of stratosphere, the temperature will increase, and in the mesosphere, if the altitude increases, the temperature will decrease. So if you have noticed, there are certain regions where there is no change in temperature. Okay, that regions will be represented with the suffix pose. So the transition zone between troposphere and stratosphere will be called as tropopause, and the same between stratosphere and mesosphere will be called as stratopause, and between like mesosphere and thermosphere will be called as mesopause. Now let's look at each of the layers. Troposphere. See, troposphere is the most important layer which you should study in detail regarding from the perspective of UPSC examination. Now, or in the case of like climatology also, many of the weather events or all entire weather event or like climate phenomena, they are limited to troposphere. Now regarding troposphere, the first thing that should come to your mind is when you hear the term troposphere, it's strong convectional current. Now convection means it's an important concept regarding climatology. Convection, it is a kind of heat transfer. Okay, and during this heat transfer, mass transfer also will be included. It means like, say, suppose this is an heat rod, this is an iron rod. Okay, I'm heating one end of it. My hand also will get heated up, or I'll get burns, right? But I haven't directly touched here. Still, the heat will conduct through the surface. If it is an iron rod, right? This process we call it as conduction. And here there is no mass transfer involved in the case of conduction, right? But this convection is different from conduction in the sense, suppose, consider like the insulation is coming to the surface and the surface is getting heated up, right? Now imagine the air particles in contact with the earth's surface. If the surface is warmer, it will also get heated up, right? So this air particles which is getting heated up, they will expand. Okay, expanding means their density will decrease. Now density decreases means the air particles, they will rise up from the bottom layer towards the upper atmosphere, right? So on their way up, this warmed up air particle, they will heat up the surrounding particles also. Convection means there will be heat transfer and there will be mass transfer. In this case, the air particles surrounding the earth's surface will get heated up and they will rise up, meaning that there is mass transfer, and they're on their way up, they will distribute their energy to the surrounding regions. So that due to convection, the temperature in the troposphere decreases with height. Now, as the height from the surface increases, the distance from the heat source is being increased, right? So the prime thing regarding the troposphere is strong convectional current, and in fact, like this feature is seen only in the troposphere. It is not there in any of the other layers, and this is the reason why like we are having like majority of the weather events, they are limited to the troposphere. It's because the water vapor and the dust particles which are denser, it should be carried from the bottom layer towards the upper atmosphere, right? And the convection is one way in which this can be done, so that the entire weather effect or climate phenomena, they are limited to the troposphere. And next, regarding the height of the troposphere. See, the height of the troposphere, they are varying. Okay, there is no like a constant height of troposphere or generally for atmosphere. Now, the height of the troposphere is higher in the equator when compared to the poleward regions or polar regions. This is because in equator regions we will be having strong convectional current, because insolation is more in the equator regions, right? So that the height of the troposphere will be more in equator when comparing it with the polar regions. Generally, as a fact, like in the equator, like it will come around as 18 kilometer, and in the polar regions it will come out as like 9 kilometers. So generally, like on an average, like we can say that the height of the troposphere is somewhere around 13 kilometers. See, UPSC won't be asking like such fact related questions. Rather than like by hearting those facts, you should understand the concept or the phenomena which are taking place in the troposphere. In fact, like if you understand the convection which is limited to the troposphere, you will be able to interlink it with all the other major features of the troposphere. Now, link the convection with the case of the height. Why we are having more height in the equator? Because we are having more convection current in the equator due to the insolation received there, right? And next, the temperature decreases with altitude. Now, as the height or as the distance from the Earth's surface increases, like the temperature will decrease, because generally the atmosphere is transparent to the incoming solar radiation, and one way in which the atmosphere can be heated is from the surface, or majorly or generally the atmosphere is being heated from the Earth's surface, not from the insolation directly, so that the temperature decreases with altitude. Now, next, it contains dust particles and water vapor. The percentage of dust particles as well as water vapor will decrease, or it is more concentrated in troposphere when compared with the other layers. Reason? Because they are much denser and they will get segregated in the bottom layers. Okay. Now, another thing, majority of the jet aeroplanes, they will often avoid flying in this layer, and the reason is like, see, this layer we are having like a more weather effect or more climate phenomena are taking place here, like, so that the entire layers, the troposphere is most dynamic. It means like there will be pressure change, there will be wind movement, there will be like cloud formations, everything will be there. Now, if you look at the cloud formations, it will reduce the visibility, right? So that is one reason why they avoid flying in this layer. And the second is like, due to this dynamic nature of the troposphere, we will be having difference in pressure in different areas, or it can be called as bumpy air pockets. Now, imagine like if you are traveling in by road, and if you are having potholes, the movement will be jerky, right? The similar manner, if you are having pressure change in the atmosphere, the movement of the aeroplanes will be jerky, and that is called as bumpy air pockets. So why the jet aeroplanes are avoiding the troposphere? Because of mainly two reasons. One is like weather phenomena, reducing visibility, and other bumpy air pockets. Now, another thing regarding the troposphere is tropopause. Now, pause means it's a transition between layers, right? Tropopause means transition between troposphere and stratosphere. Now, if you look at the tropopause, you understand that the temperature, it is being uniform there, or it is not changing there. It means that, or the importance of tropopause is that the convection will get terminated at tropopause. Okay. Now, again, going back to convection, if you really look at convection, we will be having warm air at the bottom layer and we will be having cold air above that, right? And that is why the warm air is rising up, right? Now, if it were the other case, consider if you are having cold air at the bottom and if you are having warm air at the top. See, the cold air, it will be denser, right? So it will not rise up. So that convection will not take place, weather effect, everything will terminate, or will be having very less climatic as well as weather phenomena. So this convection means we will be having warm air at the bottom, above that we will be having cold air, or with height increases, the temperature will decrease in the case of convection. See, the thing which you should remember regarding tropopause is, it's a place where convection is getting terminated. So beyond tropopause, we will not be having convection, and if we are not having convection, the water vapor and the dust particles from the bottom layer will not get transferred to the upper atmosphere. So this is why majority of the water vapor and dust particles, they are seen over in the troposphere, because beyond tropopause there will not be convection and we will be having stable conditions. And in the troposphere, why we are having unstable conditions? Because of the convective currents. Okay, so this is all about troposphere. Now let's look at the stratosphere.